All right, let's just jump right in. When you first look at Kubernetes, it can feel, well, incredibly complex, almost over-engineered. But what if all that complexity isn't random? What if every single feature is actually a solution, a lesson that was learned from a real-world failure? That's the idea we're going to unpack today.
This right here is the core idea of this whole explainer. Every component we're about to talk about is like a scar. It's a permanent reminder of a problem someone had to solve, probably in the middle of the night when everything was on fire.
And let's be honest, when you see the list of components, you got pods, deployments, services, Ingress, it's so easy to think, do I really need all of this stuff? It feels like a checklist designed to make your weekends a thing of the past. But that's the question we're answering. We're going to look at Kubernetes not like it's some dry technical manual, but more like a collection of war stories. Every single feature has a story behind it, a story born from total frustration and absolute necessity. So let's start at the very beginning. Forget all the fancy scaling stuff, forget complex routing. Let's talk about the most fundamental problem of them all, just keeping your application up and running.
You know how it is. It always starts out so simple, right? You've got your app, you stick it in a container, you run it inside a pod, and it feels clean, it feels minimal. But then, inevitably, it just stops. No big drama, no explosion. It's just gone.
And this is our very first scar. The deployment wasn't created because some engineer thought it was a cool abstraction. No. It was created because people got so tired of babysitting dead containers. It's the system basically promising you, you told me you want 3 pods running, I will make absolutely sure 3 pods are running. Period.
So, you've solved the crashing problem, your app is resilient now, that's fantastic. But applications don't live in a vacuum. Now, another service needs to connect to it. And this is exactly where networking loves to remind you who's really in charge. And here is the next massive headache. Every time a pod dies and the deployment brings it back to life, it gets a brand new IP address. Trying to connect to it is like trying to call a friend whose phone number changes every 5 minutes. It's just pure chaos. So, the service was born out of that chaos. It gives you one stable, unchanging IP address that you can actually count on. Behind the scenes, the pods can crash and restart all they want. The service couldn't care less. It just calmly finds the healthy pods and sends traffic to them. It's the Zen master of the whole system. This slide just shows that shift perfectly. On the left, you've got the chaos of trying to track individual pods, and on the right, you have the beautiful simplicity a service gives you. One stable address and zero chaos. Okay, let's move on to our next section. Your application is stable, it's reachable, and now it's getting popular. And hey, that's a great problem to have, but it comes with a whole new set of pains. So you start seeing these big traffic spikes. What do? You manually scale up your pods. Then the traffic dies down, and you're just left with a bunch of idle pods just sitting there, literally burning money. You become a human load balancer, just constantly guessing and adjusting. It's stressful. The autoscaler is the solution born from that exhaustion. It's not a luxury item, it is pure relief. It watches your CPU load, and when things get busy, boom, it automatically adds more pods. When things quiet down, it scales them back. You can finally get some sleep.
But solving one problem often just reveals another one, right? Now you've got multiple services, and maybe each one has its own dedicated cloud-provided load balancer. This seems really clean at first, until you get the bell. And it is expensive.
This is where Ingress comes in, and you should think of it not as a cool feature, but as financial damage control. The idea is really simple. Instead of having tons of expensive load balancers, let's just have one single smart entry point that can route traffic to all our different services. And this right here illustrates a classic Kubernetes pattern. You've created an Ingress resource. You've written down all the rules for how traffic should flow. But by itself, it does absolutely nothing. It's just a piece of paper with instructions on it, a wish list. That's why you need something that reads those rules and actually makes them real. That's the Ingress controller. It's the bouncer at the front door that actually checks the list and directs the traffic. Kubernetes gives you a way to state your intent, what you want to happen, and then it gives you a separate tool to go and execute that intent. Okay, so our app is stable, it's scalable, and it's cost-effective. Now let's look inward at the problems that come from managing the application's own configuration. Oh man, Everyone does this at least once. You hard-code a database URL or an API key right into your application code. And it works fine until you need to change it. Then you have to rebuild and redeploy the entire application. The config map fixes this. It externalizes the configuration so you can update it without ever touching your code. So you feel like you've made some real progress. Your configuration is flexible, but then someone points out that your database password is now just sitting in that config map in plain text for anyone with basic access to see. You've just traded one problem for a much, much scarier one. And that's exactly why secrets exist. They are the system's way of drawing a very clear, very important line. I mean, they look a lot like config maps, but they are designed specifically for sensitive data. This isn't just about being organized, it's about damage control. So let's zoom back out. When you look at all of these components together, a pattern starts to emerge. You really start to see the beauty in the system's scars. This is the key takeaway. Kubernetes feels heavy because it's carrying the weight of history. When you adopt it, you're not just getting a set of features, you're getting a battle-tested set of solutions to problems that you might not have even encountered yet. So it's really all about changing your perspective. This isn't just some random collection of tools, it's a library of lessons, and every single one was learned the hard way after something broke in production at the worst possible time. And you know, this is perhaps the most beautiful thing about Kubernetes. It isn't optimistic. It's realistic. It assumes failure. It assumes chaos. Its entire design philosophy is built not on preventing failure, but on making sure you have the tools to handle it gracefully when it inevitably happens. Which leaves us with a final thought. This way of thinking, of seeing solutions as the scars from past failures, that doesn't just apply to Kubernetes. It applies to any complex system. So as you build your own stuff, it's worth asking yourself, what failures are you preparing for? And what lessons are they going to leave behind?